Hello everyone, this is Praful John, and today we'll be discussing TensorFlow operations and PyTorch operations. We'll begin with installing TensorFlow, and in this step, we are performing some TensorFlow constants, and we are looking at the tensor. It is of shape. It is a kind of a vector. Here, then we are declaring tensor array which is of a shape 5 comma 1. Here we have a 2D constant tensor, and now we try to convert tensor into numpy using x dot numpy. So x is the tensor that we have, and we have by dot numpy we can convert into numpy array. Then tf dot zeros declare the tensor with zeros, and tf dot ones declare the tensors with one. We have variables here, and we can change the tensor variables with just a loop and assign the tensor with new value. And then we have math dot tensor, where we use different functions like square, exponential to change the power of tensor, and computing the gradient with gradient tape. So we can use tf dot gradient tape to find the gradient of the tensors. And then here we are performing end-to-end linear regression. And in this part, we are performing tf dot function. And here we are making a custom linear layer of the tensor. And here we are using non-trainable sum layer, and here we have custom dense layer with us, and here we have a recursive network. So we are performing forward and backward pass using tensors over here, and we are also performing custom dropout and custom MLP with dropout here. We can instantiate and test the model using the function custom MLP with dropout. And here we defined a functional model using the functional API. Now we have some sum operation with us. We'll performing matrix multiplication, sum of all the elements, column wise sum, row wise sum, and we can use the sum in tensors. Here we are performing element wise multiplication and summation, and different sum operation. Similarly, we can do in PyTorch. We'll start with installing the Pytorch, and then we have tensor torch.tensor, which are tensor constants in PyTorch, and then we have scalar tensor 1, 2D. We can convert it to NumPy array by dot NumPy, and similarly. We have torch.0 and torch.1, the ones we have in tensor similar to that, and we'll be computing a gradient using the dot backward and forward. And then we have this torch.random and torch.sqrt. We have custom data set which we created the data set. We load the data set, and we can define a simple neural network, simple NN, which uses the forward pass. We train the model, and then over here we train the model, and then we perform some calculations using PyTorch, matrix multiplication and diagonal elements, and trace the matrix, and so on. So that's it for the video. Thank you so much for watching.